Hi, welcome to the Trig Identities video from the trigonometry topic of higher maths. We're just going to look at a very quick couple of examples using what we know already to do a couple of proofs to prove a couple of identities. Okay, so there's some existing knowledge from National 5 that you need to remember, and it's not really highlighted in National 5 too well, so some of you may have forgotten this, but the first one is that tan x is equal to sine x over cos x. That's one that you are presumed to know now that you're in the higher. And same for sine squared x plus cos squared x is equal to 1. Okay, and actually from there you can also rearrange it so that sine squared x is equal to 1 minus cos squared x. And also cos squared x is equal to 1 minus sine squared x. Okay, so these can be rearranged as well, but just to remember those. Okay, now what we're going to do is we're going to do a couple of proofs. Now you're given the proof that you have to in the question, and what we're going to do is the left hand side is equal to the right hand side method. That's what I know as anyway. Okay, so that's where we start with the left hand side and we work our way, and hopefully we end up with the right hand side, and as soon as we end up with the right hand side we have proven this. Okay, so I'm actually going to write that down. Left hand side is equal to sine of 180 minus x. Okay, now we're going to just do whatever we can to prove that. Okay, now use and apply our knowledge, using what we know. Well, that looks an awful lot like the addition formula we just worked with. Okay, now sine of 180 minus x is really sine 180 cos x, take away cos 180 sine x. Okay, now in there, sine 180, if you think of your sine graph, sine 180 is going to be 0. So that whole first half disappears because that's 0. And then in your cos graph, okay, so that's 0, that whole thing must be 0. And then cos 180 is negative 1. So it's subtract negative 1 sine x. So my pen's been funny again. Okay, which is 0, add 1 sine x, so it's just sine x, which is equal to the right hand side. Therefore, we have proven what we've been asked to prove. We started the left hand side, we mathed, and we ended up with the right hand side. Now, some people write different things depending on what. If your teacher's really pretentious, they'll probably write QED. If they're that, they write thus proven. Okay, or if they're trying to be down with the kids, they'll write something like boom. Okay, either way, I'd use one of these two. Thus proven is probably the one I would use. But you're using left hand side, you do some maths, you end up with the right hand side, you've proven your thing there. Okay, so here prove that cos A plus B over cos B is equal to 1 minus tan A tan B. So the left hand side is cos of A plus B over cos A cos B. Now there, the only thing we can really do is this addition formula up here. So cos A cos B really means cos A cos B. Subtract sine A sine B all over cos A cos B. Okay, now a little bit trickier here, but what we're going to do is we're going to split up that fraction. Okay, so we're going to take both parts of the denominator and we're going to undo the subtract to split it up into two separate fractions. So subtract sine A sine B over cos A cos B. Okay, and then if we look at each of those fractions in turn, well, that's just the same top and bottom, so that's 1. then we're taking away, well, sin A over cos A is tan A, just from your nat 5 work, and sin B over cos B is tan B, which is, if you look back at the start, that's our right hand side equals the right hand side, thus proven. Okay, now this is something you'll very much get used to working with. They're all kind of over vein. You start left hand side, you use maths that you already know, you use some trig stuff you already know, and you end up with your right hand side. You just need to be on top of your stuff from National 5 and be on top of your addition formula as well. Okay, any issues, ask your teacher.